rate of change. I'm impressed. More of you guys remember this than I expected. Average rate of change, you'd go, okay, it's 0, 1, and 4, 1. So x squared looks like this. A point there and a point here at 4, 16. And we're finding the average rate of change, which is that slope. So this is like 0, 0, 4, 16, and then find that slope. 16 minus 0 divided by 4 minus 0. The slope of that line is 4. The average rate of change is 4. And then when does the function equal that? You're just taking x squared and setting it equal to 4. And it would be plus or minus 2 typically, but because we're only looking between 0 and 4, we just say x equals 2. So what theorem is that? That's the mean value theorem. And we found the average rate of change. So realize that rate of change, what are other words for rate of change? Slope is one. Derivative is one. That's about all I got, unless you have another fancy name for that. But we're finding, when I gave you y, we're actually finding the average value of the derivative. So when you do the mean value theorem, it's applying to the level below where you are. So like if I'm at height and I say, if I'm at height or position and I say find the average velocity, you would do this, and that would take you down a level and you would find information about the level below you. So today we're doing average value, which finds the average of the level that you're at, compared to the difference between that and the level below you. So that's kind of why I wanted to review this. So since the rate of change means derivative or slope, I don't really know what the right answer is here. I was just trying to get to this point. Since the rate of change means derivative, finding the average rate of change is finding the average value of the derivative. So the mean value theorem applies to the derivative. The average value is going to apply at the level of that we're at. And then this one, this is not very often confused with the average value theorem, but I just wanted to review it because it was another theorem. So I'm saying if you have a point at like 3, 12, and another one at 5, 1, and it's continuous and differentiable, do you have to go through 0 to get from one to the other? If you do, what's the name of that theorem? IVT, or intermediate value theorem. So let's look at 8.1. So where it says recall intermediate value theorem, I'm not really worried about that for this lesson, so I'm not going to write anything there. Average rate of change mean value theorem. What I want you to understand is these apply to the derivative. These apply to a level below where you are. If you're at the velocity and you want the average acceleration, that's down a level, that's what you would use. Anytime you're looking for the average of a level below. The average value of a function, so this applies to your level. Does that make sense what I mean by your level? Like it's the actual equation you're looking at, not the level, not the derivative, not the level below. And I think we can kind of derive this. I don't know how much that helps or not. What's the area of a rectangle? This is freaking terrifying.
I don't know. What is it? Everyone knows what it is, right?
I'm hoping. This is just y'all just trolling me and no one will say it. That's what's going on?
Yeah.
Okay. Alright, it's the base times the height. Got that? So the base is usually like along the bottom, although it can be either because it's perpendicular. It doesn't really matter. Should we go through this? Or?
Wait, so pi r squared?
let's say that was my function, and I'm looking between 0 and whatever. Let's say that's 4. The average value is just the average height. So I'm looking for height in this equation. So the idea is if I could have this exact same area, but the height would be a horizontal line that represents the average of all of these little y values, so that wherever I put my horizontal line, the areas would be the same. Like if I put a horizontal line here, that is not the average value. There's no way, because the area underneath the black curve is not the same as the area under the red. If I put it up there, like that's obviously way, way bigger. But somewhere in here, that's probably a little too high. Somewhere in here, maybe, is like the average y value. Meaning, if I found the area of this rectangle, it would be the same as the area of that curvy thing. It's weird with negatives, but you can think about it like a pool. Like most pools are kind of flat, and then they drop off to the deep end, and then it goes like that. And this is like the surface, so that's your water. The average value would say, I want the exact same amount of water, but I want the bottom to be flat. Like how deep would I go? So maybe there is the height that we would use to have the same volume of water, but we just use one height going across. So I'm heading somewhere with this. So I'm going to solve this for height. So height is equal to the area divided by the base. Fair enough? I just divided by a base. Okay? And I turned B into base for some reason. Well, I'm actually glad I did that. If I'm going from, let's say I'm integrating from A to B, and I'm looking for the average value, what's the area? How do I represent the area? This is f of x. How do I represent that area? Unsure if this is another situation where you know it and nobody's saying anything, or no one knows. Oh, now based on all your reactions, now I totally get it. Thank you. Well, you guys are killing me. Would you agree? Let's try it this way. That that's the area?
Yeah.
Thanks, Gavin. Would you agree that that's the base? Like, if it's from 2 to 5, your base would be 3, right? It's just like the difference between those two x values. So, what is going on? So the average height, or the average value, you can say it either way, is, it's this. It's this, but I don't write it this way, and I suggest you don't, because what happens is you'll work out the whole problem, but like you get sick of writing b minus a on the bottom, so you stop, and you're like, oh, I'll just put it back in at the end, but then you forget. So to me, it's easier to think about it as like 1 over the base times the area. So that is your equation for average height or average value. All it is the area of a rectangle, just kind of flipped around and then calculusized. Calculusized? You like that? That's the vibe. So, put that in that slot on your notes. Can I move on? So what's the right? Because you're so focused on calculusized. Okay. Okay, so going back here. You just filled in that there, hopefully. Do I need to write that? It's fine if I don't write that, right? Would someone freaking nod their head up and down, sideways, anything? Flip me off! Do something! Thank you. Jesus. It's like teaching a brick wall. Alright. Find find the average value on -1 to 3. So I'm looking for like -1 is here, 3 is here. So there's mostly positive, but some negative. And the question is, what's the average height? If I took the average of all these little infinitely small y values, what would it be? Or if I look at it as like, what would the height be if I made a rectangle that contained, probably a little bigger, contained the same area, but it's a rectangle instead of the curvy thing. So the average value, first of all, are we looking for information about this equation or the level below? Where do you see, how do you see that we're doing the level below? I want the value of that function. I'm looking at my level. It's not the if it wanted the level below, it'd say like find the average velocity or find the average derivative. But it didn't. I'm still on this level. So that means my equation is 1 over 3 minus -1. That's just the base. Times the integral -1 to 3 of 6 minus x squared. Oh, I know. Most of you, a lot of you guys are like figuring out that integral right now, aren't you? Stop. We're doing the calculator. So now that we've done the gateway, we go really strong, really hard into the calculator because I'm not worried about like practicing the integrals anymore. And now I'm more worried about like, can you use the T89? So we're gonna do that. Saves time, get you used to it. Too bad. Should I review how to type that in? Okay. Somebody that knows what they're doing, go sit by Noah, please, and help him.
Yeah, I'd like to stay.
Remember what happened last time?
I'd like to stay in my seat.
Oh.
All right, go to your main home screen. If you want to clear it out, I don't know if I showed you guys this, but if you hit F1, number 8 is clear home, and then you get like a fresh screen to start on. I know, right? Are we here? If you're not keeping up with me, if you fall stuff behind, let me know, because that one step quickly turns into 2 or 3, and then you're like, what am I doing? So F3, for calculus, we're going to integrate. Number 2 is integrate. And we are going to integrate from, or no, sorry, 6 minus x squared was the equation, right? Do I have that right? 6 minus x squared? Oh my god, you guys answered. Comma x is like your times dx. You're telling the calculator what variable. And then we are going from -1 to 3.
Oh.
Delete's like the arrow. The back arrow. Okay, that's not the answer though. Like if I hit enter, that will not give me the correct answer. What do I still need to do? Times by 1/4 or divide by 4, like whichever you want to do. Let's say times 0.25. That is my answer. Oh man. If you got a fraction, it's diamond enter. And it'll turn it into a decimal.
If you type it in a decimal, if you multiply it by a decimal, you'll get a decimal. If you multiply it by a fraction, by a fraction. It doesn't turn into a fraction.
We don't want a fraction.
Oh,
What? Does it turn into a decimal?
no, it was already a decimal.
Oh, okay.
I thought you were just saying that.
Good question. Are we here?
Yes.
Yes. Because the average value formula that we just did is 1 over d minus a, and d minus a was 4, so 1/4. You couldn't see it, so like it is kind of weird where it's coming from. sure. Yeah, that's fair.
Mine's now just on auto decimal. It's like always decimal. Okay. It's like
Bro.
I shouldn't say always. I can't think of a time when you would need the other, but I don't want to say always. Okay. Now, the second, so we all have this. So remember when I drew that like rectangle, the red one I just drew, that height should have been at 3 2/3, and then that would have had the same area as the blue stuff. The second part of that, I believe, says where does the function attain that value?
Let's assume this. At least I respond.
When does that's true? When does the function assume this value? Is that what it says?
Yes.
So we want to know when the original function equals that. And the calculator's doing that too. So hit F2 for algebra because we're going to solve an equation. Solving is just algebra. So hit solve. And then I'm going to go 6 minus x squared equals. And we're going to just hit answer and put the previous answer there so it doesn't round anything. But I feel like I'm doing too much here. I hit like 3 buttons, so I need to slow down. Teaching the calculator to anyone is always like a regular. Yeah. What? I'm not done. So I want to set that equal to the answer I just got, right? So if you hit second negative sign, it takes your previous answer, but it doesn't round it, so it's more accurate. So it's actually using like 3 2/3 now instead of 3.66667. Not a huge difference, but more accurate. That's my equation. I hit comma x, tell the calculator what variable I want you to solve for. And you should get these two answers. One of them I'm going to ignore. Which one and why? Negatives is not in our window, right? Did we get those two numbers? You got them?
I did.
Yeah.
Why do we have to put the comma after that?
Two reasons. One, if you don't do an error. And you're telling the calculator, like, this is the variable I want you to solve.
It's like something like X.
Yeah, because sometimes you might have x and y.
Wait, well, we need to use comma y.
If your equation was y, yeah, which will happen. Any other questions? All right, I'm going back. Like, how long are we talking? Like, you want to admire it for a while, or you just need to see it?
Wait, is this data side? Did you clear it again?
F1, and then 8 is clear. Warren, how are we doing? You're basically like the remedial student now, so I need to know how you are. Braylon, you got it under control? No, that's fine. Hit diamond enter. That's right. The square root of 21 3 is right.
He knows it's exactly 1.5.
So right there. I'm gonna like do that. So it's just gonna tell you square root of 21 How are you good now? Is that for me? You just said no. But you were talking about Will, right? Okay. That's good. She's still not answering.
Talking to her.
Oh, wait. Oh,
I don't know why.
Okay. Are we okay at 1 now?
It's just like the 1.5 number for Windows function.
Average value was the 3 2/3. Or square root of 21 over 3. Or no, sorry, 3 2/3. And then this is like the negative 1.5 or the 1.52 or whatever we just got. Okay. Okay, let's look at now we gotta really, what's the difference between the average rate of change and the average value? So the average rate of change applies to what level? Applies to the level below. The average value applies to current level. So what is the average height during the first 3 seconds? Well, this equation is in height. They're asking the average height. They're asking about the level I am on. So that's the average value formula that we just used. So I'm going to throw that in the calculator. You guys try. You guys do it. I'll do it in a second. But find the average value of this during the first 3 seconds. Carter, do you not have your calculator? Is that why? Wait, what? Did I know this?
That's like oh, wait, I already forgot.
16 t squared.
Oh.
I mean, I can see why you'd say that. I was just writing it out first. I'll guide you. 2 for the arguments means that your syntax is wrong. Like something's wrong. Not enough commas or not enough like things. Does it know what?
Yes. Like if I do X is 0.
I don't know what he's asking. Are you 100% confident you're right?
Yes.
Okay.
I got through physics.
So, if you want to follow along, if you want me to guide you, F3 calc, integrate, -16. You can put t, you can put x, whatever, and then when you put the comma variable, you put the variable that you use. So I'll do t, just to show you that one. -16 t squared. Was it 41 t and then plus 10? And then I'm going to tell the calculator, what's the next thing I tell it? It'll give me a giant error if I put x right now. T. Because I did it in t, so I got to put t. If you did it in x's, put x. That's probably where it is. And then it was from 0 to 3. That
70.5.
That will not give me the correct answer. What do I still have to do? Times by 1/3 or divide by 3 is good. So I got 47 over 2. Or if I want to hit diamond enter, that's 23.5. Either, fine. Both fine.
How did you change it to the decimal?
Diamond enter.
Okay.
Questions? Things I can help with. Are we getting where we're supposed to get?
I did it in
Just like your geometry class.
This, yeah, when I teach calculator stuff, everything turns into like 7th grade pre-algebra. All right, so average velocity. Stop your words. Oh, I want to put it back. Average velocity is asking about your level or the level below you. That's the level below you. So you've got 0, comma something, and 3, comma something. If I plug in 0, that's got to be 10. If you plug in 3, I would use a calculator. -16 times 9. Is this -11? That's my That one's not that bad in your head, but it's not simple either. And then you're just finding the slope, like the regular old advanced algebra. This is an advanced algebra. You do not need calculus. You're plugging in to that equation, and you just find the slope between them. So it's like negative 11 minus 10 over 3 minus 0. So negative 21 over 3 or negative 7. What would the label be on that? Feet per second, right? We're in feet and seconds, and at the velocity level, it would be feet per second. Questions on feet? Yeah. Is that thing stupid? Do you want to use that? I think it sucks. What? No. I want you to use the calculator. No, here's why I didn't, because I'm a pro. You were not. If you are. So this, in like regular geometry, what would happen right now after all of that is this would happen, and then you would go, how do you turn it on? You're in the wrong one. Are you like? Do number 3. Do 3. Use your calculator.
Mine actually won't work. Also, there's weird things on it.
So you try to do better. Stop!
I haven't had the chance to use the batteries. You should find out just
Why does this happen? If I teach a normal, like before I got on the calculator, no one responded to me, no one shook their head, no one talked. After I teach a calculator, you guys turn into bozos. Why is that?
we never get to use our calculators.
So now you're just so excited.
We taught an entire year.
Yeah, we haven't used them at all. How do you what? Mode. Should I go through how to put it in degrees? Got it. It's in the mode menu. You need it in degrees. Wait, no. It's supposed to be in radians. It's supposed to be in radians. Mode and then read the freaking menu. Figure it out. It says it right there.
Leave the fourth one. Mr. Davis.
Yes.
Are we looking for the level
In what? You guys, I can't even hear the question. 3A. 3A, you're looking for the level you're at.
This is average rating.
It does? Or maybe I'm wrong, but hold on. Oh, 3A, you do go a level below. So that's, yes. And then 3B, you go a level below a level below. Oh, yeah. All right, stop. Hold on. Tony, you were right, but like missed something. And I missed something too. We are currently at the rate. we are in inches per month, we are at the rate. So when we're at the rate and it asks for the average rate, aren't we at the same level? Because this is a rate of change. They're asking the average rate of change. So we are at that level. The next one asks for the change of the change. So that's the level down. If you're at the rate of change and you take the change of that, you just took another derivative. So like this one is average value, and this one is average rate of change. Thank you, Eric. So did you get negative 5.36 for this one? Oh yeah, half of that? Negative 2.68?
Mr. Davis.
Yeah.
I typed out the whole equation, but what do we do at the end again?
I don't know which equation you're talking about. So it depends. What did you get for an answer?
Like I typed in the full equation, but I don't know how to do that in the base.
It's from 10 to 12.
Oh.
So you just do like times 1/2. Is that what you're asking?
Yeah.
Okay. Are you're taking the derivative, you said? Don't do that. Because the mean value there gets you to the level below. So you don't need to be at the level below. You need to be. You what?
I didn't get that answer.
So B is mean value.
Wait. Mr. Davis, I didn't even get that answer.
Yeah, but it's the average rate of change of the rate.
Average change of this rate. That'll get you the same thing. But I just want to make sure you understand like what you're doing and why. Yes, I agree with you. Do you understand now? Like we're good. Okay, Antonio, what are you asking?
I got negative 0.91
Are you in degrees or radians?
radians.
Then you type something in, Rob.
Dot. Okay, what do you do?
So you can share the
Yeah,
answer with them, or you're just gonna tell them?
Mr. Davis, for the first problem, do you use this one or this?
Radian. First problem. This.
Wait, so I'm multiplying it by
You are at the rate. You're at. You want to stay at the
Oh,
level?
we multiply by 0.2. Yeah. Oh, wait, so we're supposed to times by 2? So, no. No, both these ones are wrong. I know.
Alright.
That's why I told you I have
I don't know.
Yeah, I don't know how I got that. But I had the same answer as well.
Look at what you see how this is 2 sine of x minus 1. Yours says 2 sine of x minus 1.
Oh, is the x supposed to be? Oh, and then the minus 1.
You gotta pay attention.
How do I even change it?
You talking
I said negative squared.
It'd be like inches squared per month. So the label on, I didn't do part B yet, but the label labels inches squared per month.
Inches per month or inches per month square? Because inches square is not a square. Isn't that kind of like crazy?
It's like inches per. Oh, per month, per month. Yeah, okay. Yeah. You're doing. Like I'm so confused right now. Some people are like, how do I turn my calculator on? Some people have the whole assignment done before they walked in. So like, just kidding. Just so everyone knows. No, I'm not saying it's your fault. It's no one's fault. I want you guys to go up to 12. Your homework is 1 through 12.
Yeah, you can.
I would. You are allowed to. I would encourage you to. But you don't have to. Yes. Like, so from now on, I want you to use your calculator whenever possible. You need to get used to it, and it doesn't make mistakes, and humans do. Yeah. What do you guys get for B? I didn't do that yet. Negative 0.38. Is that what you said? Is that what you got? Okay. First 5 months, so. Wait, negative 0.038, right? Oh.
Why did that?
Oh, I get it. Oh, it's just here.
See this equation?
So,
Sorry, I'll get to it.
for part B, you're talking about? So, part B, we are at the rate level. They're asking the change of the rate now. Change puts you on now. So, this is basically saying we are at the first one. Okay. So, it's the mean value theorem, not fair enough. Yeah, part B, Matthew, I don't know if it's negative point like 3836. Oh, you're good? I feel like I've lost all control of all things. Have 1 through 12 done by tomorrow, please. No, tomorrow. Have it by Saturday. And it'll be good for Monday. Did you have your hand up first? I apologize. So it's like, well, you're not. You're gonna set up.
It's now we get to see the real stuff.
Exactly what you got.
It's your problem. This is
I'll be back.
Wait, what's her name?
you're in a line.
Yeah.
It's easy.
this here, which is in inches. This one has
I got. Let me check.
this is asking for the range.
2.6 inches. 7.
So you want to go down.
Oh.
Really look at this. Our way matter. What was yours?
I am consistently getting 0.7671. Coincidentally, exactly double the
That's
exact.
kind of solid.
It's coincidentally double the right answer.
Oh, I.
There's no way you yourself.
When I put this in my calculator.
Wait. No, I'm on B.
So it's that's the time and energy.
Oh.
Okay, and
But you could also just say
so I don't have anything written down. I have
2 sine of 5.
R5 minus R0 over 5.
Zero.
Jessica has the word.
But either way,
If you would like to see what it actually looks like.
Is it okay to just play answers on practice?
That was sorry.
I mean, you better make sure you know how to do it. Divided by
I got 2.5.
Okay.
oh, we need to zero.
I'm still doing IC while. Wait, why are you writing stuff?
Are you guys doing like minus?
Will you Well, try that. I don't know. We're doing on the show. Until now, we're okay. You understand what I'm saying? Okay. Could be because was waiting. Sorry, I'm trying to get through one as fast as I can. Are you staying after school? Who else was staying after school? Parker, are you staying after for your game? What?
Monday I do have
You want to do it Monday?
It sounds like a no, my girl went to Africa for 2 weeks. I'm being genuine. I think
No, that's not true. But if you were lying, that's like an amazing lie.
I
It's
know,
so specific.
but I'm being
Monday after school?
but like
I actually. It's a little sketchy. I feel that part.
I'd say after school day. If you take it. I literally don't care. It's your choice.
Frankly, that makes it easy.
Sorry.
So
No.
you want to don't do it for me.
I although I'm not
Why, what's the time? Oh. You got shaved tonight?
I think I just shaved my head.
I think you started asking for 5-0. Give me thumbs up, down, sideways, what?
Oh, wait for this?
For the calculator.
Oh, okay. Oh, no, calculator.
For the calculator. It takes batteries. My calculator's broken. Try the batteries?
I'll get that.
So that makes it two.
It takes triple A batteries.
I already wrote it on my
You said you needed help with the calculator.
I think the other class is going to be
What other class?
from last year.
Other than Morse. But it can't be because yeah. At first I thought it was but it's not. Yeah.
When you said it, I was like,
Successful. Well, it's like,
Congrats.
no.